get into today is something that's probably new for the majority of you. And what we're talking about is organizing data. Well, let's organize data because in life, mathematics is filled with numbers. Mathematics, you're going to see numbers everywhere. However, in life, you see even more numbers. And you see numbers everywhere in life. But usually, in life and a lot of times in mathematics, you're given problems where it's just a big mess of numbers. Nothing's really organized. And that's where you come in. And you say, hey, if I can parse all of this jumbled information in math, or if I can parse and break up the world, the real world of my life, and break it up into small pieces. Parse, guys, do y'all know what that word means? It means to break up, to organize, to make really complex systems chopped up into really easy little parts and pieces, like Lego sets. You know, there's a lot of different pieces to it, but if you organize it, you can understand it and build some pretty cool stuff. But let's get into what I'm talking about here with actual values, and let's just take a look at a real sloppy set of numbers. All right, guys. So the first thing that we're going to deal with here. Get ready to write some notes. And here's what we're talking about. I'm going to go a little bit lower than that. Let's just say that I am giving you the numbers 10, 30, 45, 20, 15, 10, 10, 20, 15, 40, 30, 35, 20, 15, 10, and 5. Hey, guys, these are pretty jumbled up. They don't really make too much sense right now. And, well, makes sense because I haven't given you any information on it, one. And then two, once I give you the information, you could still say is, hey, these numbers are really jumbled still. But let's take a look at the problem. There are these people that work at a company, and these people got together and said, you know what, let's just talk about how far, we're at lunch. We're just going to talk about how far we have to travel. And, oh, gosh, I have to go 10 miles to work. And someone else says, I have to drive 30 miles to work. So these employees at a company listed an estimate of the distance they travel to work from their home in miles. So we're going to use a line plot in the long run to actually visualize what this is talking about. The cool thing, guys, in math is that once you look at a jumbled set, if you can organize it, list it, organize it, and then create it or turn it into something visual, okay, you can make a lot more sense. So I'm going to say this is the distance that they travel. Dean, you need to get some notes out and put that book away, buddy. Or actually, you don't have to put that book away. That's probably good. So you got your distance here. And the first thing that I'm going to do before I even create this line plot is I'm going to create another box. And this box I'm going to use to just organize the data, make it a little bit more clean. Whoop. Yeah. I know. All right, guys. So we're going to call this first set of values the distance, and the second set of values the frequency. So this I'm just going to put a big D, and this I'm going to put a big F. Is that really tough to see? So let's just say, hey, these values are going to be 5, 10, 15, 20. That 15 is real sloppy, so I'll fix it. 15 and 20, and then obviously I'm moving up in increments of 5. 25, 30, 35, 40, and 45. Hey, Dean, you need to be paying attention and working with us, bud. Put that book under your desk. Shut it. Okay, so now we're going to look at the frequency of all these. Well, how many times does 5 occur on the list? And you can see, well, 5 only occurs one time, so you're going to cross it out and put a 1 for the frequency. The frequency lets me know how many times each value occurs. So the 10 occurs 1, 2, 3, and 4 times. Kathleen, you want to go grab a water? And then the 15 occurs 1, 2, and 3 times. 20 occurs, 20 seems to occur here another 3 times it looks like, if I were to look on the graph. I can do that here, 1, 2, and 3. 25 occurs no time, so I'm just going to skip over 25 and go back and count how many times 30 occurs. 30 occurs 1 time, 2 times, and then 35, 40, and 45 occur 1 time. So 2, 1, 1, 1. These are my values. I'm going to zoom out here, guys. Okay, so now the next step from this point is let's create a line plot and see what's going on. So what's cool already is you've already listed and organized some, and it makes a little bit more sense. But let's see if we can make it a little bit even more visual or connected. Yes, ma'am. Huh? It's a 35 right here. There's not a 35 on there. Maybe yeah, you know what? I didn't type it. So you know what? We're going to cross out 35 and just skip over it. Huh? Oh, you know what? I mistyped. It's supposed to be 35. So that 36, I want you to call it a 35. Fair enough? Or we could just cross it out. Either one. I'm going to stick with it and say that 36 is a 35. So back onto the chart here, I've got 5, 10, 15, 20, 25, 30, 35, 40, 45. That looks like a 9, so I'll fix it. Okay, and now moving on to colors. Hey, let's put an X over each number, how many times it occurs within the frequency. So 5 occurs 1 time, so I'm going to put, that needs to be thicker. So I'll put 1 X down for 5. 10 occurs 4 times, so I'll place 4 X's down. 15 occurs 3 times, so place 3 X's. 20 is 3 times, so we get 3 X's. 25 occurs none, so skip it, and 30 is 2. Then 35 through 45 each have 1 X. All right. So now this is where it gets really neat because you can see up here, you can actually visualize all of this unsorted mess at the top. You get a visual to where it says, hey, guys, the people that drive from work, the majority of these guys have to drive from, well, 10 to 20 miles. And not too many people drive under 10 miles, and not too many people drive over 10 miles. The majority of our employees drive between 10 and 20 miles. So that's the cool thing about creating visuals from problems. You can actually visualize it, one, you can understand it and interpret it. But in order to do that, you need to be able to take large bits of unsorted information, list it, organize it, chop it up, analyze it, and then graph it somehow to where it's a visual representation. So we're going to move down to the next step here. So that was just how do you organize data visually, representations of your information or your data. So now let's scroll down. We'll go to the next set here. Say, all right, well, that was organizing data. Now we're going to look at creating stem and leaf charts here. So here's what we're going to look at. Let's say that you get this, let me do this. Let's say you get a stem and leaf plot, and what it's telling you, you got your stems over to your left, your leaves over to your right, and what you have here are just a 0, 1, 2, 3, and over to the right you've got a 2, a 5, 3, a 3, a 7, and an 8. 0, 2, 6, and a 1 and a 7. And what we're asked to do is take all of this information and organize it in a list, a set of numbers. So take everything here and organize it. And one way that I can do this, or actually the only way I guess I can do this, first I've got to ask myself, what do the stems actually, yes, give your hand up or, no. So the first thing is, what do the stems actually, what's up? What do these stems, what do they stand for? And they stand for, yes ma'am? Yeah, they stand for the 10th place, but they also stand for the first digit that I use when recreating the number. Yes, but these are our 10th values, and these stand for my first digit. So they're the first digit, and then therefore that means that the leaves got to be the what digit? They're the second digit in the number. So the second digit. So let's take an example here. If I were to look at this 3, which is the first digit, and the 7, which is the second digit, I'm going to call it 37. It makes sense to call it 37. Or the 1 and the 3 are 13. So now it's time to make a list, make it real clean from here. So 0, 2 is actually going to be 2. And then 0, 5 is 5. And then, let's see here. So 1 and 3 is 13. Then 13, I got another 13. I've got a 17, an 18. I'm going to go back to that and fix this stuff up some. You can keep on organizing your data while I fix this up some. Go ahead and finish writing this list. 2, 5, 13, 13, 17, 18, 20, 22, Dean, 26, 31, and 37. Okay, so that is how you create a stem and leaf plot, or actually a list from a stem and leaf plot. So now, let's move on to our next problem where we're going to take a stem and leaf plot and we are going to actually, girls, from here, you're going to create, from a list of numbers, create a stem and leaf plot itself. So I'm going to scroll down, give some room here. And let's say that these are the values that you're given. Everybody stand up. Stretch up to the sky. Look up on the screen. Stretch up to the sky. Dean, we're waiting for everyone's hands to go up to the sky. Shake your fingers out. Shake your hands out. All right, guys, shake your right leg out. Okay, shake your left leg out. Stand up. We're waiting for you guys to stand up. Take a deep breath in. Let it out. I'm going to wait till Dean's standing up nice and straight. Okay, now have a seat, guys. All right, so now I've got another list of values here, and it's just as jumbled and unsorted as the list before. But these numbers, they represent visitors of each exhibit at a museum. And what we're going to see is, well, these are the actual amounts of people that come in to look at an exhibit of a museum. So now that's what we're going to try to create a standard plot. All right, let's do this. So again, the first thing you got to do is create your two columns. You got to create your two columns so you have a left and a right. And you have your stems and leaves plotted. So now the first thing I got to look at my numbers here are to say, hey, what kind of numbers am I dealing with? And I see, hey, I don't have 20s, but I have 30s and 40s and 60s and 80s. I'm dealing with a lot of tens value numbers. So what you're going to do is say, hey, starting with the lowest number, you got to find the lowest number first. And it looks like 39 is the smallest. So you're going to say, hey, this value is going to be 3, but it doesn't stand for 3. It stands for 30 something. And then you're going to say, hey, what's the largest value? Look at this chart here. And Alex, what's the largest value here? Yeah, 89 is the largest. So you're going to put an 8 down here, but you're going to go in sequential order from 3 to 8. And again, each of these numbers, they don't stand for 3, 4, 5. They stand for 30 something, 40 something, 50 something, 60s, etc. So now I've got 30, and the first number, or actually the only number for 30s somethings is 39, so I'll put a 9 down, and I can cross it. Now let's move to the 40s. Well, there are no 40s, so skip over it, leave it blank, and move to the 50s. We've got two 57s. Looks like that might be it for that number. So you do 2 7s here next to the 5. What's up, Dean? No, sir. You got to take notes, buddy. Oh, you think you're going to survive, but you need to be taking notes. So now, moving on to 60s. Looking at the 60s, you got 68, 63, 68, and 65. Well, let's start with the smallest, which is 63, then 65, and then 2 68s. So I'll put a 3, a 5, and 2 8s. Okay, now the next step is to say, hey, what about my 70s? Well, I've got a 74, a 76, a 77. I also got 70 over here, so I'll say 70, 74, 76, 77. So 0, 4, 6, and 7. Then finally, I've got my 8s. I've got 82, 84, and 5 and 9, 85 and 89. Okay, and now my chart is completed. I've completed my stem and leaf plot. And now I can actually see that, hey, you know what? The amounts of people that they go to the museum exhibits, they're typically the size of these exhibits are 60s through the 80s. These are pretty large exhibits that people are coming to see, and I can circle that just to give a little bit better of a visual. But there aren't too many people exhibiting the viewing the exhibits in the 30s to 50s groups. Okay, moving on. Let's do, this is the tough one, and this is the tricky one. Get your pencils ready and your writing ready. We're going to do a back-to-back stem and leaf plot. So I'm going to do here, let's take a look at our new problem. And let's say, hey, you know what? Colleges are packed with numbers. And when you guys go to college, you're really going to realize that the first thing that you do, your psychology class, one of your first classes, has about 200 people per class or per section. So let's say the different sections of psychology are filled with 270, 245. I'm going to lengthen this out some. 286, 267, 237, 267, and 261. These are all the courses for psychology. And then also, you take Spanish because you like the foreign languages and you want to travel some. And your Spanish classes, or most of the Spanish classes at your college, are filled with 277 people, 281, 260, 275, 235, 239, 242, and 268. Okay, so these are all the class sizes. They're pretty large classes, guys. Look here, 39. Think of this. I'm working with about 19 people. It's a challenge to work with 19 people. Think of how tough it's got to be for a professor to work with 200 plus students. So out of 19th here, I got about, let's see here. We'll just round up to 20 and say, I got about 5 of my students who are probably off. 5% of my students are off task. And think of that as 5% of 200. 5% of your students, that'd be like 10 students off task. That's crazy. Okay, so now let's move on. We're going to actually look and create a back-to-back stem and leaf plot. The way to do it is, first off, I'm going to create a box here. Dan, get your head up. All right. Now, the way we're going to do this is I'm going to turn this, you know how we were doing 2 columns with our other stem and leaf plot? This, I'm going to do 3 columns. All right. Now let's just say, the first thing I need to do here before I even start writing information down, actually, I guess I could do this a little bit extra. What I could do is I am going to choose my color and say, guys, we're going to call this psychology, the psychology course. And this will be the Spanish course. And smack dab in the middle, just like before, these are my stems. So the middle is stems. That's really sloppy, so I'm going to fix the writing on it. What's up, bro? Are you impressed? I'm just kidding. Okay. So now the next thing that you want to do is say, hey, guys, really got a lot of information here. I don't know what to do with it, and I don't really know how to look at it. But, you know, there is that stem and leaf plot, so maybe I can do a back-to-back here and organize this data here. And the way to do it is, just like before, let's organize this or list it from least to greatest. And, well, we'll do that. But also, let's say, hey, how can I label these? I could say 200s. I could put 200s right here in the stems. But there are a lot of 200s, right? A lot of different 200s. So let's move to the next digit, the 10's value again, and say, well, there are some 240 somethings, some 270 somethings, 280 somethings, and also a Spanish 280 somethings. There's this, I can break it up, parse it, make it a little bit more visual and easy to work with. So that's what we're going to do, and by doing that too, we're going to look at from least to greatest. And the smallest number up there, it looks like 237 or 235 might be the smallest number. So now what I'm going to do from here, say, okay, and it looks like my first value that's going to go right there is a 23 for 230s. I'll put a 23 right here. And I'm going to carry that on all the way up to, it looks like my largest number is 286. And there's no 290s, so I'll stop at 28. '23, 24, 25, 26, 27, and 28. And now from here, all you got to do is organize your data. Okay. Fletcher, you're facing forward, bud. Stay focused. Oh, Fletcher, you looking back here? You're welcome to do that, bud. You can look on that. So the first one I'm dealing with on psychology, the smallest number is 237. So let's just put a 7 down right there. And let's move on to the next one. Any 240s? Yeah, I got a 245. Put a 5 down here. And any 50s? No 50s, so we skip 50s, but see there is a value for 267 and 261, so I'll put a 1 down. Then I'll do a comma, and I'll do a 7. And then what I'll do from here is say, hey, 61, 67. In fact, I got a second 67. So I'm going to put another 7 down. And now move on to the 70s. I have 270 and then 286. So I'll put a 0 here and a 6 here for 286. Now, guys, if you look at this chart, I'm not going to, if I took this number here, the 1, I'm not going to read this as 126. No, I'm going to say, hey, this is 261, 267. Okay. Now, this is the back side of the stem and leaf plot for the other. If you were just to cover this half up, like so, you would just see, hey, this is the stem and leaf plot, but I've got a backside, so we call it a back-to-back stem and leaf plot. So now I've got my Spanish. Well, the smallest number here is 235, so I put a 5 down. And then my next number would be 242, so cross it out, put a 2 down. Oh, I've got a 239 as well, so I can put a 9 down next to the 5. Also, let's see what other numbers. Any 50s? No, no 50s, but I do have a 60. So 260. And then also a 68, so I can put an 8 down. And then, well, I got a 275 and a 277, so I'll put a 5 and a 7 down. And then finally, ending with 281. Now, the cool thing here, guys, and now I'd read this value as 275 or 270 for psychology. Now, the cool thing here is you've got another visual that makes sense. The largest classes, they seem to be in the 260s for both Spanish and psychology. You can say, hey, this college usually fills its classes with 260 students or within the 260 range. Cool stuff. This is neat. So when you have a lot of information jumbled up, You can parse it, break it up, list it, analyze it, and finally turn it into a visual using a line, hold your thoughts, a line plot or a stem and leaf plot. Your homework is on the study habits. It is 281, problem 1, and page 282, problems 7 and 8. Have a great day. 3 homework problems. 3 problems. Huh? 282. Yep. And what days are you going to be gone?
Thursday.
This Thursday and Friday? Can you send me a notepad up in there? Yeah. That's what I need. I'm going to put a P for testing, okay? I don't know your name at the top of my head. And then I'm just making a note for me this Thursday and Friday you need a packet. Take care. What's up, Cameron? I can't talk to you right now. Give me a second, okay? I gotta talk to. Peter, step outside for a minute. Step outside. Christian, I'm gonna have you step outside today. Cameron, I'll get you a pass before I hang out. Z, what's up, bud? I'll get you both passes back. Hang out for
Dude, you should be punting. Cameron, are you in some pies now? Oh, a 37 in the house? Oh, we got a 77.
guys, no backpacks in here. Nick, no backpacks in here.
And I got more than problems with
Backpack out. Take off your water.
No, I changed nationality. Oh yeah. Hey, Connor.
Oh, he's on the ball.
What the heck is this? What is this? Especially dog.
Yes, they You want
Yeah,
a
that
cupcake party? Next week, bread and whipping.
probably actually tastes good.
You know what that? Enter your home store. Free starting next Monday, October 26th. The bulletin board judged by student council on Friday the 28th. The most creative woman for the podcast were of cupcake party.
I've got to work with these guys. You got to wait.
Remember, so don't forget to scare away those drugs by dressing up. One day is I bought Jesus is that's on North Free for anything made of blue cheese. Don't forget, celebration messages the record course. Remind your parents to go online, purchase tickets. Remember, no lunch is served in the cafeteria that day. There will be food, inflatable, markable games, hair tinsel, and hair dye with lots of Westlake red and blue. We will be ready for the football game that night. Fireworks, floors, and boards. This year, Celebration Westridge is having a cupcake decorating contest in conjunction with a cake walk. You can win free tickets if your cupcake wins for the funniest, most original, most artistic, or most spirited. Whether you enter or not, please bring in sweets for the cake walk. Have a great day doing it the Wildcat way.
supposed to be his, give me a second here, I think it's first and last initial in his ID. Hey guys, your online textbook for Holt, what is it?
Your first initial,
Your first initial, your first initial of your first and last name, then your student ID,
yeah,
and then and then the password's the student ID, or the same
it's the
thing?
same thing,
It's the same thing, yeah.
and it's capitalized.
That work out? Thank you, coach. Here, fellas. Let's see. Yes, ma'am, Hannah.
Can I use the computer?
Yep, go ahead. We use one character. Here's the so this is actually the solver problem right there. It's not, you're not answering this question. You're not answering this question. This does not determine the knowledge does. This is one of the most important. Roll yourself. Let it go. And that's tough. And you'll have to face it to make it go. You can cut that and say that's it. If you want to do that, I'll have to get out. Want to go there? Hey, you can. What do you think of that Edmodo? Yeah.
It's cool beans.
Who do you use it for school here or somewhere else? What did you use?
White.
Science teachers.
Hey, Fletch, find some other work to do. It's gonna take a bit. Find some work. Just read or something for about 10 minutes.
I thought I got like some of these answers right, but you said they were wrong.
Probably wrong. You want to talk to me about them? I can show you the answers right now. I don't have an answer key on me. So you want to talk about them? There you go. Where does this play? Where does this play? Symbol stuff. Time plus name. 24. Plus negative 0.9. So 5.6 is going to be smaller than 0.9. Bye-bye. Whoa, you're throwing that out? You mind if I keep it? It's okay. Huh? Thank you.